Okay, so you might remember arithmetic sequences from junior cert. So it's just another word for linear patterns, okay? And you'll remember that the first difference is a constant in these type of sequences. So for example, 3, 7, 11, 15. You're just going to find the difference between the second and the first term, the third and the second, and the fourth and the third, okay? So 7 take 3 is 4, 11 take 7, 4, 15 take 11, 4, okay? That's called your first difference. And it has to be a constant if your sequence is to be arithmetic or linear, okay? So your first difference is a constant. Now, you have a formula for the general term of an arithmetic sequence, okay? Your general term is a plus n minus 1 times d. Now that is given to you in the log tables, okay, so you don't have to learn it off. That's here on page 22, okay? So you'll see this arithmetic sequence, there's your general term, okay? And it also tells you on the side, A is the first term and D is the common difference, okay? So that's on page 22 of your log tables, okay? So A is your first term. D is your common difference. Okay, and to get D, you just do T2 minus T1. You take the first term from the second term, or you take the third term and you minus the second term. Okay? T of n plus 1 minus T of n. Okay? The term ahead take the term. So T4 take T3 or T3 take T2. Alright, so that's just how you find your D. We just do our loops, but it's important to know this for a little bit further on. Okay. Now we'll just do an example of dealing with arithmetic sequences. Can I get rid of the board? Yeah. Okay. Okay, so find the nth term. Now, another word for nth term is your general term, or Tn. Basically, that's saying find the rule, okay? Find the general term that will get me any term in my sequence. So find the nth term of this sequence. Hence find T20, T21 and T21 minus T20. Okay, so they want the general term, then they want the 20th term, then the 21st term, and then they want what's going to happen when I take away the 20th term from the 21st term. What should happen here? Have you any idea? Okay, we'll wait and see.
Is that the first difference?
Lovely, exactly. You'll get the difference. Perfect, well done. Okay, so if we're looking for the nth term, first of all we need to figure out what type of sequence it is. Okay, so to do that you're just going to do your loops or get your differences. Okay, so it's 3 minus minus 2. Okay, or you're at minus 2 on a number line and you need to get up to 3. So you're adding on 5. Okay, 3 minus minus 2. Here it's 8 take 3 and 13 take 8. So you know A is your first term, D is your common difference. So A is the first thing you have there, T1, so that's minus 2. D is your common difference, and we're going to go and get our formula from our log tables. So to get my general term, I just do A plus n minus 1 times D. Now for Tn, I leave n as n. If I wanted T1, I fill in 1 instead of n. T2, I fill in 2 instead of n. But I'm only interested in the general term, so you need to leave that n. So Tn is A, which is minus 2, plus n minus 1 times 5. So Tn is minus 2. Now, n minus 1 times 5 is the same as 5 here in front of the bracket. So you're going to do 5 by n, 5 by minus 1. So that's plus 5n minus 5. So Tn is 5n minus 7. There's your general term, or your general term, your Tn. Okay, now part 1 wanted T20. So that just means instead of n, put 20. 5 times 20 minus 7. So that's 100 take 7, which is 93. Part 2 wanted T of 21, so just fill in 21 and take 7. That's 98. And then part 3, T21 take T20. So the next term take the previous term. 98 take 93, which should be your common difference. Okay. Are you okay with that question?
Yeah.
Anything you want to ask about that? Okay, let's do another example. Can I get rid of the board? Okay. Find the number of terms in the sequence 1, minus 3, minus 7, minus 11, minus 2, 5, 1. Okay? This is not an infinite sequence. Okay, it doesn't just keep going, it does stop here at minus 251. Okay? Could you tell me what type of arithmetic sequence is it? Increasing or decreasing? Decreasing, yeah, because the numbers are going down. Okay. Now we want the number of terms in the sequence. Okay. So basically we know this is the last term. So we're going to try and find out what term number that is, and that will tell us how many, or find the number of terms, how many terms are in this sequence. So to do that, we'd need to get our general term, and then we'd need to put it equal to 251. And that would allow us to find out what term number is minus 251. Is it the 5th term? Is it the 10th term? Okay, so first of all, we need to find our differences. So minus 3, minus 1. Okay, this one, take this one, so that's minus 4. Minus 7, minus 3. Okay, that's going to be minus 4, and minus 11 minus 7, that's going to be minus 4. Okay, so A is my first term, D is my common difference, and then throw it into your Tn formula. Okay, A plus n minus 1 times D. and just multiply out minus 4 by n minus 4 by minus 1. Minus by minus is plus. Okay, so there's your general term. Now, that allows me to find any term by filling in n, the first term, the second term, the third term. But it also, if I put it equal to something, it allows me find what term number that is. Okay, so I'm going to put minus 4n plus 5 equal to minus 251. And when I do that, I'm going to find what n is. Okay, so minus 251 minus the 5. And then divide, so n is 64. So that's telling me that's the 64th term. So how many terms are in this sequence? Well, there's 64. So when I'm filling in for n, I'm finding the first term, the second term, the third term. When I put it equal to something, I'm finding what term number it is. Okay? Are we okay with that? Okay, I'm going to do another example. Can I get rid of the board? Okay. Okay, so in an arithmetic sequence, T4 is 6 and 3 times T2 is equal to T10. Find the values of A and D and hence write out the first 6 terms of the sequence.
Why is there 3 in front of the T2?
Because it's telling you 3 times the second term is equal to the 10th term. Okay, so I'll show you what that means in a minute, but basically it's just saying 3 times this is equal to this. Okay. So they haven't given me a huge amount of information on the sequence itself, on the pattern of numbers, but we'll be able to find it. Okay. Now they've told me T4 is equal to 6, and they've told me it's arithmetic. So that means I'm immediately using this. T4, what does T4 tell me to do? What am I putting in instead of n? Yeah, put in 4 instead of n, okay? So T4 is equal to 6. So T4 is A plus 4 minus 1 times D. Okay, instead of n, I'm putting in my 4. So that's A plus 3D. And what did they tell me T4 was equal to? So put that equal to 6. What do you think is going to happen here?
Simultaneous?
Lovely, yeah. Good. Okay, we're looking for 2 variables, so we're going to have to do simultaneous equations. So that's T4 is equal to 6, okay? Now the next thing they've told me is 3 times T2 is equal to T10. Okay, let's get T2 and T10 first. So T2 means fill in 2 instead of n. and T10 means fill in 10 instead of n. And now they've said 3 times T2 is equal to T10. So 3 times whatever T2 was, that's that down there, is equal to T10. Then you're just going to multiply it out. 3a plus 3d equals a plus 9d. Now if I'm going to do simultaneous equations, I want the a's, then the d's, then the equals, then the number. So all of these are going to come over. So 3a take a is 2a, 3d take 9d is minus 6d, and I'm left with nothing. Okay, now, because I have an equals, I could divide everything here by 2 if I wanted to make my life a little bit easier, and I'd be left with a minus 3d equals 0. But if you want, we can just leave it. We have these two equations, 1, 2. And we're going to do simultaneous equations with those two. Okay, and that'll allow us to find a and d, and then we have to write out the first 6 terms. So I'm just going to write those one on top of the other. Can I get rid of the board? Okay. So a plus 3d equals 6 and 2a minus 6d equals 0. So multiplying the top line by 2, I'm going to be able to cancel the d's. So 2a plus 6d is 12, 2a minus 6d is 0, and they cancel. So 4a is equal to 12, a is equal to 3. And then all you're going to do is throw that a in one of those lines. So a plus 3d equals 6, 3 plus 3d is equal to 6. That 3 comes over, becomes a minus. So d is 1. So actually my general term is 3 plus n minus 1 times 1. Okay. So 1 by n is n, 1 by minus 1 is minus 1, so I end up with n plus 2. That's my general term. Okay, the reason I need that is because they've asked me for the first 6 terms. Okay, I know my first term is 3, and I know the difference is 1, so it's going to go 4, and then 1 and 1 and 1. Okay, if you wanted, you could use this to find T1 by filling in a 1 here, then a 2 here, then a 3, 4, 5, 6. Okay, I'm just going to use the D because I know the difference is just 1 each time. 1, 2, 3, 4, 5, 6. Lovely. So there's your pattern of numbers. Okay, they asked for the first 6 terms, so there they are. Any issues there? Okay, I'm just going to keep going with this.
Where did you just fill that in to get the numbers at the bottom?
I did, yeah. Or I know my first term is 3 and my difference is 1, so I'm increasing it by 1 each time. So that's what I actually did. I just said 3 is my first term, then the next one is add 1 4, add 1 5. But you could have totally filled it into your TN as well, 1 up to 6 to get your answers. Okay. Can I get rid of the board? Okay. So if p plus 2, 2p plus 3 and 5p minus 2 are three consecutive terms of an arithmetic sequence, find the value of p. P is a real number. Consecutive terms means one after the other. So basically they're telling you p plus 2, the next term is 2p plus 3 and the next one is 5p minus 2. If it's arithmetic, what do you know?
The first difference is constant.
Lovely, thank you. Okay, we have to use that. The first difference is constant. What that means is the difference between T2 minus T1 is the same as the difference between T3 minus T2. The difference between these two is the same as the difference between these two. Does that make sense to you? Okay, so a little bit of algebra involved here. Okay, so T2 minus T1, that just means find the difference between these two. So 2p plus 3, and I'm taking away the first term. And then the third term, and I'm taking away the second term. Okay, I'm just finding the differences, but because it's not just nice and easy numbers, I'm writing it out. Okay, so the difference between them is the same as the difference between them. All you're going to do is tidy up now. So that minus is outside the whole term, the whole bracket, so minus with the p, minus with the 2. And same here. Okay, and all you're going to do is just keep tidying. So that's p plus 1 is 3p minus 5. Letters to one side, numbers to the other. So p take 3p is minus 2p, and minus 5 minus 1 is minus 6. So p is 3. Now if they asked you to write out the terms, you know that p is 3, so it would be 3 plus 2, which is 5, 2 times 3, 6 plus 3, which is 9, so 5, 9, and then 15 take 2, 13. 5, 9, 13 would be your pattern, okay? Now, just one more example. First of all, a little note. Can I get rid of the board? Okay, so a little note to prove that a sequence is arithmetic. They want you to prove it, okay? you must show that t of n plus 1 minus t of n is a constant. Okay, so all they've given me is Tn equals 2 over n plus 1. Determine whether the sequence is arithmetic or not. So I have my Tn and it's got n's in it. Now to do this, you're going to find out what t of n plus 1 is. Okay, you're not going to try and get a pattern of numbers here. You're actually going to leave your Tn and your t of n plus 1 with n's in it. Okay, so Tn is 2 over n plus 1. T of n plus 1. N plus 1 means instead of n, you're putting n plus 1. Okay, n plus 2 means instead of n, you're putting n plus 2. So it's no longer 2 over n plus 1, it's 2 over, instead of that n, I have n plus 1 plus 1. Okay, I'm just replacing that n with whatever I have here. So that's 2 over n plus 1 plus 1, which is n plus 2. Even though that's in brackets, the only reason I put it in brackets is to just make it really clear that it was n and now it's n plus 1. But you don't have to keep it in the brackets.
Miss Butler?
Yeah. I didn't hear you, Jane. You okay?
Oh, sorry, I think I'm my internet. Can you hear me now?
I can.
You know that formula? Would you only use it if it's arithmetic?
Yes. Yeah.
Arithmetic, whatever.
Yeah, this one.
Okay.
That's only for arithmetic. Okay, so they want us to decide whether,
Add 1 to both sides, is that all you did?
as in here.
Yeah.
So do you see my formula? It tells me I need to get t of n plus 1. So to find t of n plus 1, instead, yeah, that's basically what I did. Instead of n here, I now have plus 1. So instead of n here, I need to have plus 1. Okay? If I wanted, now I don't want it because it's nothing to do with my formula, but if I wanted n plus 2, instead of n, I'd have n plus 2 plus 1. Does that make sense? You're just replacing, instead of n here, I've n plus 2, so instead of n here, I've n plus 2. Okay? If I wanted t of 5, instead of n, I'd put 5. That's all I'm doing, but in this scenario, I'm replacing it with letters instead of numbers. Okay?
And is it always plus 1?
Yes, it's always plus 1. This is your formula. T of n plus 1 minus t of n. Okay? So you'll do the same thing each time. Now, I have my t of n plus 1 and I have my t of n. And I need to show that when I take them away, I get a constant. Okay? A constant means I should have no n's left. So let's take them away. It's going to be t of n plus 1 minus t of n. Now, what do I do in this scenario? Go back to your algebra.
Common denominator.
Thank you. Lovely. I need to get a common denominator. What's my common denominator going to be?
N +1.
n plus 1. Now, does n plus 2 go into n plus 1? Remember, I need to account for everything on the bottom line. N plus 1 by n plus 2. Okay? N plus 1 goes in there, n plus 2 goes in there. So they're both able to go in. Now, here I had n plus 2. Now I have n plus 1 by n plus 2. What did I multiply this by to get this?
+1.
N plus 1. So that means if I multiply the bottom by n plus 1, I also have to multiply the top by n plus 1. I have a minus in the question and I have a 2. What did I multiply this by to get this?
n+2.
N plus 2. If I multiply the bottom by n plus 2, I also have to multiply the top by n plus 2. Okay, then we're just going to tidy it up. 2n plus 2 minus 2n minus 4. And I'm left with minus 2 over n plus 1 by n plus 2. Now, I have an n in my answer. That means it's not a constant. If it was a constant, it would just be a number. It would be 2 or it would be 3. Okay? Because I have n's in my answer, it's not a constant. Because if n changes, my number changes, so it's not staying constant. So this is not a constant. Okay, therefore Tn is not arithmetic.